Hello students, welcome to the Yupp Master. Today we are going to learn the important concept related to speed, acceleration and change of velocity. So let's have the interesting topic. Let's see. Yes, speed, velocity and acceleration. Have you seen that the person he used to go in a particular path? Just have you seen that how he was going to cover? He used to cover the distance with a different speed. I think so you are having the good experience with the bike riding. I hope so you are all enjoying while riding. Yes? Please have a look. This is the time to discuss about that. The person who is going to revolve in a particular path, he used to get that the distance covered. We are going to take that average distance covered in the total time of duration. Right. Let's go for another one. We are going to talk about that. Yeah. We would like to take that generally speed. Yeah. While you are talking about that speed, it is the rate at which we are covering the distance. Covering the distance. Yes, within the given time, we are going to cover the different distances. So, we are going to talk about the direction. There is no restriction on the direction in what direction that you have to go. You would like to have the freedom to move in anywhere, no doubt at all. Now, the rate, suppose you are going to take that different vehicles, they are all having that their capability to cover the distance, because it depends on the efficiency of the engine and all different parameters. How does it will consumes that fuel, and we are going to take the different conditions also. Now we are going to take that the rate at which we are covering the distance. Yeah, that is we are taking that speed is equal to distance by time. We can take that very clear. Now if you are going to take that average speed, sometimes we used to calculate that average speed. How you will take that average speed? Let's see. Suppose if you have taken that case, this is a case we are going to deal. This is A to B. Yeah, he has covered the distance, half of the distance with the speed V1, half of the distance with the speed V2. Yes, please take that. Half of the distance he has covered that with V1 and V2. Now at the time you can calculate that average speed, that is 2 V1 V2 by V1 plus V2. You can put that many intervals, whatever it may be, between the source and destination. Yeah, between the 2 points you can put many intervals. You should take, let him to take that rest, whatever it may be. Suppose you wants to take that 3 by 4th distance covered. Next one, 1 by 4th distance covered with the speed V1, V2. Yes, but the total distance is D. It is very clear. They will give a number of problems, but if you are knowing that concept to how to calculate that average velocity, you should divide, that is you can take that A and B. Now if you are going to take that, this is the distance covered, this is the speed V1, V2. Now easily you will take that how much time does it takes to cover that much of distance with the speed. If you know that speed, sometimes they are going to mention that kilometer per hour. kilometer per hour. Just you can, yeah, please take this. Yes. Now, generally, if we are going to take that, that is kmph. They are going to give that speed of the vehicles, that is in terms of kmph. You can convert very easily. That is you will convert into meter per second, kilometer per hour. It's very easy. Meanwhile, you have that 18 by 5, 5 by 18. Just you have to take that. Now, if you are going to take that, yes, very simple method. You should go for in clockwise. I am going to use to move this in clockwise. I am moving this. You should remember. Yes, you have to confirm. Yeah, kilometers to meters, meters to kilometers. Just you have to write down. That's better. You are going to get that kilometers to meters and meters to kilometers. Just you have to take that. You will get the answer. It's not a big task. So the first step, you have to convert that. Right? It's very clear. Just you have to multiply with the given. Suppose they have given you 72 kilometer per hour. So you need to multiply with 5 by 18. Just you have to take 20 meter per second. All about to know, whatever it may be, light. Now it is the time to go for discuss about that speed. What do you know about that additional information regarding to the speed? So it is going to be changing. You can take that different cases also. At the time, you should talk about that acceleration gradually increases, suddenly decreases. You have the different tasks. So you can take that acceleration. Yeah, just you have to use this. Yeah, you will take that acceleration, deceleration. So it is very clear, just you should take that. With respect to the time, it is going to be decreases. With respect to time, it is going to be increases. Rising that bike, rising that speed. These are all very clear. Now, if you are going to take that acceleration, it's going to be decreases. It is increases, speed increases, speed decreases. Very simple, you can talk about that. Now let's go for the problems to solve this. Yeah, we have very clear that we would like to know about the rate at which the body covers the distance along a given path. It's very clear. Now if you are going to take that, speed is equal to distance covered by time. And between two intervals, you need to find out that. But over the many intervals, how you will find out that? Let's see. This is one simple problem to solve that 200 meters. They have given that a train 200 meter long is moving. It has been crosses the bridge at the speed 54 kilometer per hour. The time taken by the train to cross the bridge of the length 0.4 kilometer. How you will solve that? These problems are very easy and standard model. Right. Yeah, please take that. First of all, you need to take that total distance covered. Distance covered by total distance covered. You have to take that length of the train and you should take that 200 meters plus 0.4 kilometer. Yeah, we have to get that. Yes, to cross the bridge of 400 meter. So it is very clear, we have taken what it has been crossed that. Already it is in 400 meters. So this is 400 meters. So it's going to be crossed that. It is let's take that. Yeah, you can take, let us assume, yeah, it crosses that, it is going to travel that 200 meter, that is equal to 200 plus 400 meters, that is 600 meters, very clear. But they are going to know about that, what is the total time taken by the train to cross the bridge. Yeah, they have given that distance, and t is equal to question mark. But while you are going to take that, how much time does it takes to cover the distance, means you need to know about that speed. Yeah, that is speed is equal to, just you need to know about that speed. Yeah, that is equal to 54 kmph. It's very clear. That is 54 into 5 by 18. Just you will take that meter per second, 15 meter per second. It's very clear. Now, what is that formula we can use? T is equal to, yeah, distance by speed, let it be v. So you can take that 600 seconds by 15 meter per second. Yeah, sorry, you can take that unit, it is in terms of meters. Just you need to know about that 40 seconds, right? Let's see that answer, it's very clear, it's going to be taken. Sometimes they have given you that train has been crossed the bridge within 30 seconds, what's the speed of the train? It's very simple to know that. So if the train has been crossed that bridge within 20 seconds, what is that speed of the train? Yes, you have to do that. They will ask you, if they have given you, yeah, they have given the problems, depending on that you can calculate that speed also. You will calculate speed of train is also calculated by knowing that time, by knowing that d1 plus d2 by t. It's very clear. So d1 is the train and d2 is the length of the train they have given, and that length of the bridge also d2. You can easily add and you can get that answer. Very simple. Let's go for another one. While you are going to talk about the time, does it decides one interval to another interval. How? Let's see. So within the fraction of seconds that there exists a change in the speed, if you are going to take that consideration. So if you want to observe the rate of change of the speed is going to be identified with respect to the time. So you can take the time interval. If you are going to take that, yes, you have to take that time interval. Here the time interval can be chosen from one incident to another incident. How does it changes the displacement and the distance covered? Then you can decide that whether it is a moving with the uniform speed, uniform velocity. Easily we will find out that at equal interval of time, does it covers the equal distance? Then you can say it is in the uniform motion, no doubt at all. But simply the accelerator, it's going to be raised. At that time, that car is going to be having that situation to have the speed, high speed. Okay. Now we are going to talk about that direction. Yeah, it is a time. Just we can take that. Yeah, we can take time. Yes, we can divide that T1, T2, T3 Just you can take that first interval to second interval. So it has been taken that motion along yeah, it has taken along 1D, that is say x axis. Let us assume along x axis. You can easily find out that. Suppose if you are going to take that with respect to the direction, it has been moving in a specified direction, easily you will identify that. So you will get that displacement yes, it is also going to be identified x1, x2, x3 like that you can take at interval. So you will take that x2 minus x1, yeah, x2 minus x1, yeah, you will get that x3 minus x2, yeah, it is going to have that variable, you can easily identify that. Yes, easily we can take that. Now it is very clear, we are going to take the motion along one dimensional 1D, and it will covers that the distance, yeah, with respect to the time, the it's going to have that displacement, it is going to possess the different values, right. Now can you take that velocity is equal to displacement by time. By time, easily you will find out that. Now if you are going to take that, that is x2 minus x1 by, yeah, you will take that t2 minus t1, let's assume, yes, you will take that. Yes, please have a look. It covers the different intervals, different speed. Easily you will find that it's going to have, look, yeah, from the origin it covers. As the time is also going to be increased, it is easily identified. Now let's go for another one. Yes, velocity, that is going to be rate of change of displacement, is going to known as velocity. Now it is very clear, we are going to take that velocity is equal to displacement by time. That's very clear. One thing you have to know, that displacement, it follows the direction. If you are going to get this displacement, it has direction, it has direction, so that velocity is a vector quantity, is a vector quantity, vector quantity. We will easily identify this, right. Why it is going to have that direction? What is displacement? The shortest distance between the 2 points in a specified direction. If you are going to reach in a specified direction, then you will get that shortest path, shortest distance, right. Now let's go for another one. Yeah. Now if you are going to take that, is there any relation between force and acceleration? Yeah, you can take that. Yes, he is the person first, is a one person A, B and C. He used to get that force F1, F2, F3, just he used to get that force. So just you have to take that, yeah, please take it. Yes. They are using that different forces, force acceleration. Just you have to take that force and acceleration, you will get that A1, A2, A3. Let's go for this case, you will take that. You used to get the different forces, first one, second one and third one also, he used to give that, and the direction has been changed. If you are going to look into that matter, here you will confirm that T1, T2, T3. So the time, with respect to the time, you are going to take that one object, it has been applied by different forces. You will take that first one is F1, second one is F2 and third one is F3. Now the acceleration is different in these cases, and the angle is also, they are going to get that, they are going to project that body with the, yes, let's see, yeah, he used to get that projected in this direction, and the force is going to be varied. When the force is going to changes, what happened? There exists acceleration. The speed of that ball is going to be different. Now it's very clear. Now we are going to take that, yeah, force, yes, that produces the variable force. Force produces acceleration. Very clear, it produces the acceleration. Now, apart from that, the force is same. If they are going to take the direction, the direction changes. What happened? Let's see, direction changes, there exists a acceleration. In about direction changes, you can take that velocity is also changes. Velocity is also changes. Please observe this one. This is very clear. In what direction they have thrown up the ball? In one direction, in another direction. So he used to raise the hand, particular angle theta, he used to raise the hand one particular angle. He was not at all going to consider the angle. Three cases are there. So the direction which decides that acceleration. It's very simple example. Suddenly the driver is going to change the direction of the bus. Always it is a general case. What happened? Speed will also changes. At that time there exists a change in speed and velocity. You will find out that speed also changes. Yes, very clear. Now you have to observe that different directions, which are very important. Different directions. Yes, directions are going to be, yes, you will take that directions changes. Changes from A, B and C. It's very easy. So if you are going to take that variable force and the direction is also, then you will get that acceleration. Very clear. Because earth, we are going to get that attractive nature, that is acceleration gravity due to the earth attraction power, it's going to be same. But whenever you are going to take that, changing the direction and all, so initially it is going to be exerted a different force, right? Very clear. Let's go for relations, that is, you can take, yeah, that is force F is equal to ma, that is equal to m into v minus u by t. Very clear. F is equal to ma, just you will take that. So it is going to take that mv minus mu by t. Let us assume rate of change of momentum, rate of change of momentum. Yes, according to Newton's second law, force is nothing but it's going to be rate of change of momentum. Very clear? Let's erase some part to understand. Yes, you can take that. Yeah. If m is constant, let if m is constant, just you have to take that. This m is constant, we will take that. So, what you will take that momentum? Yeah, there is a force external. Yes, you should take that rate of change, that is equal to F external. This is also one, yeah, until it is going to be having that constant mass. That is very clear. Let's go for problems, all of you. Yeah, it's very clear to have that observation. Yeah, you will take that. Let's have one special case. Yes, you can take that. Yes, you can observe if with the help of the force, take that. Here, two persons are there, they are going to apply the force, yes, force and acceleration. Let's see, it's very simple, just they are going to get that path also and the force. Yeah, this is going to be force F1, this is going to be F2 force. So, the direction is also different, direction. So, this is also one direction. Yes, you used to get that. Yeah, here F1 is greater than F2. That is the case we are going to discuss that. How does it changes that magnitude? It changes that acceleration. Very clear. Now, if you are going to get that the magnitude of the force and the direction, they will also affect the acceleration. Very simple, just you are going to apply that more force, there exists a drastic changes in speed, it's going to, and it has been here only, this position is there, but it has reached the net, finally the destination. So, in this situation we can understood that matter. Here what happened, you will take that its speed is going to be v, here that momentum is equal to, we can take that mass into that velocity, just we can take that. We will talk about, this is P1, that is equal to mv, let us assume. This is P2, that is equal to mu. Yeah, in this case the momentum is also different. First case the speed is also different. Second case that speed is different. It is going to be lesser due to the less amount of the force. So, we can easily identify that path and the direction, how does it will changes that acceleration. Yeah, let's have the problems. Yeah, acceleration, very clear. Let's go for that acceleration. We are going to take that uniform acceleration, constant acceleration, non-uniform acceleration. We can take that the previous case is going to be non-uniform acceleration. That is, it's very clear. Uniform acceleration, you should confirm that in the different interval of the time, it's going to have that same. Yeah, if you are going to take that, just the rate of change is observed uniform. How you will get that rate of change? In at different time intervals, it is having that same speed. We can identify very easily. It is moving with the constant speed even at the different time. Generally, change of velocity in a unit time is also called acceleration. Acceleration is a one vector quantity. So, acceleration is nothing but that change in velocity by time. While you are going to talk about that representation, easily you will identify that A is equal to V minus U by T. Now, you can take that initial and final velocity. Here, U is the initial and final velocity, very clear. Yeah, acceleration is a vector quantity and the direction of acceleration is in the direction of the change in velocity, that is easily identified. Right. Now, if you are going to take that velocity and acceleration and their changes with respect to the direction, they are all dependent. Easily we will identify that. Yeah, dimensional formula is also identified. That is L T minus 2. Simply you will identify that L by T divided by T. You will get that. Yeah, that is LT minus 2. Easily you will identify that. Just you can take average acceleration. We are going to take that average acceleration. Yes, you can take that. If you are going to take at different intervals, you can take the value that is of V1. Yeah, you will take that V1 at V1 T1 first interval. Yes, you will take that V2 T2 at the second interval. Now, if you are identify that, we are going to take that first case and second case. We are going to calculate that average, means we have to get that final and initial. We have to take that final values and initial values. That's very clear. We are going to identify this one. Yes. Now, let's go for instantaneous acceleration. If you are going to take that instantaneous acceleration, easily you will understood that matter. Yeah. Now, if you are going to observe that from one time interval to, yeah, if it are going to take that T1, T2, T3, T4, yes, T5. If you are going to identify that, yeah, it's going to have the observation. Yes, at the point, at any instant of time, you are going to identify that at T3 or T4 or T5, whatever it may be. And that if you are going to take that T2 minus T1 is very small, very clear. T2 minus T1 is also very small. It is going to be getting in the small interval of the time. You can identify that the acceleration of a body at instant time. If you want to measure at T2, T3, T4 and T5, T6, whatever it may be, but the body is going to be having that continuous motion. At any point you want to take that its acceleration, it is known as instantaneous. Right. Let's go for that. Acceleration of a body at a particular instant. At a particular instant means that is going to be either t2 or t3, t4 and t5. That is called instantaneous acceleration. But you have to take that these intervals are going to be small. Yes. Right. It was represented. It is very, very clear. It's going to be very small. Now we can easily identify that the acceleration of your body at a particular instant is called the instantaneous acceleration. Very clear. Let's go for another one. Yeah. Okay, right. Let's go for uniform acceleration and constant acceleration. We can take that uniform acceleration and constant acceleration. Very clear. Yes, if you are going to have that at different intervals, it is going to be same. At different intervals of the time, the velocity is going to be same. Then it is going to be in the uniform acceleration. Yeah, the velocity of your body change by equal amounts of intervals at a different time. Then it is said to be in uniform acceleration. It is said to be in the uniform acceleration. Easily will identify that. Now it's very clear. Yes, you can take that. That is a case in the uniform motion. Just you will observe that in case of a uniform motion, the velocity of that body is going to have that change, that is uniform from T1 to T2, T2 to T3. You can take that any two intervals, it is going to be same, then it is in uniform acceleration. Very simply you can take that if the velocity of your body change by equal amounts in equal intervals of time. That is very clear. Now we will confirm that its formula is A is equal to V minus U by T, or V is equal to U plus AT. Right. Okay, all of you, if you are going to have that continuous observation and monitoring, it is easy for you. So don't miss a single class and convey to all your friends about this app master, how we are going to narrate that all the lessons. Thank you very much.